Welcome to Amplified Education, your exam prep friend. Today we are doing electric circuits. And before we discuss this question, please pause the video and try the questions on your own. Remember, when it comes to electricity, there might be more than one way of arriving to the answer. Please try the other ways that are available for you to solve these questions and share them in the comment sections. So this particular question says, a learner wants to operate an electrical device using a 12-volt battery that has an internal resistance of 1 ohm. The electrical device has a resistance of 5 ohms. To achieve the required operating voltage for the device, the learner sets up the circuit shown below. When the switch S is closed, the device operates at its maximum power output of 5 watts. Now, the first question says we must define EMF. So EMF is the total energy supplied per coulomb of charge by the cell. If we were to describe EMF in a different way, obviously EMF stands for electromotive force. However, EMF is actually the total voltage that you have, or the total promised voltage, or the voltage that a battery has before it is connected to an external circuit. Because once the battery starts operating, there is some lost volts inside the battery. The next question, 1.2, says calculate the current that passes through the electrical device. The electrical device there has a resistance of 5 ohms, and we must not forget that its power output is 5 watts. So we could use the formula P equals, and we're looking for current. We could use P equals I squared R. We already have power, which is 5, and we're looking for current, which is I squared in this context, and then the resistance is 5. And so there, I squared is equal to 1. And therefore, I is equal to the square root of 1, which is 1 amp. And so the current flowing through the electrical device is 1 amp. And then 1.3 says we must define the term resistance. Resistance is a material's opposition to the flow of electric current or electric charge. Calculate the resistance of resistor Rx. Now, if we look at our drawing here, this is where Rx is. The 3 ohm and the 9 ohm resistor are connected in series. All right, and we can see that A is a junction. This is where current actually splits. Let us write our given data. All right, let me just consistently use the black pen. 1.4 data given is the EMF, which is equal to 12 volts. We have the baby R, which is equal to 1 ohm. We have the resistance of the device, all right, which is 5 ohms. And then we have those two resistors connected in series, the 3 and the 9 ohm. And then we have the 4 ohm. We do now have current, all right? The current, the main current in the circuit is 1 amp, and I think that's very important. Okay, so the current is 1 amp. So in order to solve this question, first and foremost, we need to calculate the total resistance in the circuit. We can do that by using the formula RE equals IR plus I baby R. And then we can substitute the EMF, which is 12, the current, which is 1, plus the current again, which is 1 there, and the internal resistance, which is 1. And so R would be, bring that over, that's 12 minus 1 is equal to 11 ohms. Now, that 11 ohms is inclusive of the resistance in parallel plus the resistance in series. Very, very important. That 11 ohms includes those two sections of resistance in the circuit. And so we could write an expression for that. We could say the total resistance, again, I like red, but let me just use black for this question. R total is equal to R series plus R parallel. And we know that now R tot is 11, and R series, we know there's only one thing connected in series, and that's the electrical device. And so R series is 5, then plus R parallel. Now, R parallel, we do not know, obviously, because we are looking for Rx. So now R parallel is equal to 11 minus 5, which is equal to 6 ohms. Once you have that, you could use the equation that we use for finding the total resistance in parallel, which is 1 over R parallel equals 1 over R1 plus 1 over R2. We mustn't forget now R2 involves Rx and the 4 ohm resistor. We already know that R parallel is 6. So 1 over 6 is equal to 1 over 12 plus 1 over Rx plus 4. All we now need to do is to just make Rx the subject of a formula, but we must just multiply both sides here by 6. Right? If we multiply both sides by 6, then obviously these 6's cancel out. And then what we are left with there is just 1 over, is 1, obviously 1 there. Okay, that becomes 1 over 2. Bring that over, that's going to be 1 minus a half, which is a half. And that is equal to 6 over, that's 6 over Rx plus 4. And then we could then say there a half is equal to 6 over Rx plus 4. Then we could cross multiply there and say Rx plus 4 is equal to 12. Then subtract 4 from 12, Rx should be equal to 8 ohms, and that's the value of Rx. Then the next question says you must define the term power. All right, and that is what 1.5. Power is the rate at which work is done, or the rate of doing work. And that comes from the formula P equals W over T. Switch S is now open. Will the device still function at maximum power, right? Yes or no? And so the obvious answer would be a no. All right? And no, simply because when you cut off that path in the circuit becomes a series circuit and the resistance increases, which means the current decreases, and current is directly proportional to power, to the power dissipated in the electrical device. And so the device will function at lower power, and so it might not even work. So then it says that you must explain your answer. Oh, okay. If we're going to explain our answer, then we could say that the resistance of the circuit increases, the current decreases, and because according to this formula, P equals I squared R, remember R is constant because it's still the same electrical device. Power is directly proportional to I squared. And if I, therefore, then decreases, then power dissipated also decreases. And that's the idea behind that. And the last question is about the cost of electricity. And to calculate the cost of electricity, that's 1.7. Cost would be equal to power times the time that you use the device for, multiply that by the price per unit. So the power that we were given earlier on was 5. And remember, the unit is measured in 1 kilowatt hours, which in this case is 2 rands 80. So 1 kWh is 2 rands 80. Your power must be in kilowatts. So you need to divide that by 1,000. You multiply that by 10 hours. So the time is already in 10 hours. You can leave that like that. And the price, which is 2 rands 80. And then you can find your answer there in rands. Let's punch that in. It's going to be 5 over 1,000. Multiply that by 10 and multiply that by 2 rand 80, which then gives you 0.14 cents. So you spend 14 cents to operate that electrical device for 10 hours at a cost of 2 rands 80 per unit. And that's how you'd solve this question.